Hey there, I'm Joe Weems. Before we get into the video, I want to remind you about ng-conf 2023 happening in Salt Lake City, Utah on June 14th and 15th. Head over to ng-conf.org to check out the speakers, check out the talks, and to get your ticket before they all sell out. We'll see you there.
Hi, I am Misko Hevery. I'm a CTO at Builder.io. I did a bunch of these things. So as a CTO of Builder.io, we work on this thing called the headless visual CMS system. Currently, we're working on this project called Quick. You might have heard of me from things like Angular JS and Angular, Zone.js, Clean Code Talks, and then I had something to do with Karma. So that's me. So let's talk about a web application startup performance. Does it matter? Well, if you look at, for example, web.dev, which is run by Google Chrome team, they have lots of evidence that basically says, yes, this stuff matters. And it makes totally intuitive sense, right? Because the longer you have to wait for a response from, you clicking on a button, if somebody sends you a link to a hottest shoe that you absolutely have to buy, you go to that link, you want to push it to, add to the shopping cart, and if that add to the shopping cart is taking forever, you're going to be like, you know what, never mind, I really don't need that shoe, and you're going to leave. And so Google knows about this, and they have this thing called Google Core Web Vitals. And Google Core Web Vitals basically just says like, look, we're going to measure this, and we're going to report this to the world because we think it's so important that, if things don't get measured, they don't get reported. Now, to kind of keep it track of it, there are actually two ways of recording this. Google Web Vitals actually instruments the Chrome, and so this is real-world behavior. But before real-world behavior can happen, they have something called PageSpeed or Lighthouse, which gives you kind of numbers to show like, hey, we think your website will be this good once actual stuff actually happens. But the thing is, if you look at most websites, they're not actually green. They're either red or yellow. And what's going on? So we at Builder.io, we care about e-commerce websites. But this is true for all websites all across. Once a real website becomes production, things don't look so well. And so the question becomes like, what is this? What can we do better about it? And what's interesting that even websites such as Amazon that live and die for selling stuff, right? They fully understand how important it is. They're one of the best sites out there in terms of performance, but even they don't get 100 out of 100 or anywhere close to the green category. So one of the things we have done is we kind of wanted to show you how much of the problem this is. So these are 50 highest e-commerce websites, and notice that they're all red, with few exceptions in the yellow, again, yellow being Amazon and IKEA and a few others. And yet, even companies that live and die for the performance, even they have troubles getting there. And so who's responsible for having slow websites? And most people naturally blame the developers. They say, you know what, your developers messed up. But does it actually make sense? Even if Amazon, that can afford to buy the most expensive, the best developers in the world, and arguably they have the best developers in the world, and even they can't get the best possible website, is it really the developers' fault? Also, if it was really developers, there should be some examples of some real-world websites that do real traffic that actually are performant. But it seems to be kind of a myth. So I'm going to say that I think it might be some other problems like our tooling and our framework and our approaches. And so the thing about frameworks is that the frameworks really give you the mental model for the system, right? They basically say, this is how I want you to build the application. They kind of set the stage, they set the rules, and as a developer and as the tools that you have for this framework, you just have to follow the rules. And so maybe these rules that we have are not the best possible rules. If you look at the amount of JavaScript that's produced on a website, over time, this is from, name escapes me right now, the Web Archive, you can see the amount of JavaScript is increasing over time. And the question you might be asking yourself, well, why are we just getting worse and worse? The thing is, we're not getting worse. What we do is we're getting our sites to be better in terms of interactivity, in terms of what you can do, and so on. When you come to a website today, there is so many things you can do, right? Like you see a shoe, you can rotate it from a different angle, you can look at it from different sizes, you can like have an augmented reality to see if you like it in your house, if it's a piece of furniture or something like that. And so the amount of JavaScript is just going up because our websites are becoming more and more powerful. And I don't think that this trend is going to stop. But if you look at the performance, it's not so good. So how do we make the sites faster? To demonstrate this, we built this tool called the Performance Insights. And what this tool does is basically takes your site and then sends it to Google PageSpeed, the lighthouse, and says, what score do you give it? And remember, PageSpeed is not the real production. It's kind of the lab experiment where they have slow network and slow device emulation. And it says, if you do, for example, on Priceline.com, you get 36. And a lot of people talk about optimizing images, and so we try and optimize the images for this website, and we submit it again, and we get the same number. Which means, at least for Priceline, they're doing a wonderful job of optimizing their images. They don't need to do anything better. We do the same thing about CSS, and we get the same score back, which means, again, for CSS and images, this site is doing a wonderful job. But what if we could optimize JavaScript? Now, in this particular case, optimizing JavaScript, nobody really knows what that is, so we're just going to trick the system and delete JavaScript. If you delete JavaScript, wow, your website is immediately 96. So what if we could figure out, instead of, somebody's laughing back there, it's like, yeah, delete JavaScript. Well, deleting JavaScript is not realistic, right? But the question is, what if we could somehow figure out a way to not do all of the JavaScript all at once? Because when you navigate to a page, you don't need all of it at once, right? You don't click on every single button on a website all at once. You interact with it over time. So instead of delivering it all at once at the beginning, can we spread the JavaScript over time later? And so we think, looking at what deleting JavaScript really is, it's a good proxy. And so we did this for top 50 websites. And you can see the first column here is what the site currently gets, what it gets when we optimize the images for it, what it gets when we optimize the CSS for it, and what it gets when we optimize JavaScript, or in other words, delete JavaScript. And you can see just about every website can become green if we could only do something about this JavaScript. In other words, I'm trying to convince you that JavaScript is the problem and something needs to be done. And so at least for the top 50 e-commerce websites, which is like kind of the professional stuff, right? As an industry, we seem to be doing a good job at optimizing images, and we're doing a good job optimizing CSS. There's not much else we can do. Maybe for the non-top 50, the mom and pop shops, maybe they could benefit from image optimization. But for the most part, most people get this right. But the JavaScript optimization is the thing that nobody knows how to do, and the thing that would give you the most benefit if you could figure out how to do that. Okay, so it turns out your websites really have two kinds of JavaScript. There's the first-party code, which we'll talk about in a second, and there's the third-party code. Things like Google Analytics, Facebook Pixel, HubSpot, Segment, and so on. This is the code that businesses install in their website that, well, they kind of want visibility into what's going on, but this third-party code is, well, more JavaScript. So what if we could take this JavaScript and instead of running it on the main thread where it competes with every other script and also your application, making your application slow, what if we could move that code over to a web worker? The reason why this is important is because JavaScript is single-threaded. So putting a whole bunch of stuff on the main work means putting a whole bunch of stuff on a single core. But all modern devices are multi-core. So if we could just figure out a way of getting it off of the main core into a separate core, well, there's a whole other benefit that we can get. Now, this might look simple and straightforward, but there's a catch. And the catch is that these scripts, like for example Google Analytics, they want to set up listeners and observe what the user is doing. And therefore they need DOM access. And guess what? Web worker doesn't have DOM access. So what Partytown does is it creates a proxy of your main thread DOM and puts it inside of the web worker. And so Partytown is an excellent way for you to just move all of your third-party code onto a separate thread. It's kind of a no-brainer because no matter what technology you're using, no matter what framework you're using, you can just benefit from this particular thing. So but let's leave third-party code aside for a second. Let's talk about first-party code. You're using a framework. Well, that framework's producing JavaScript. So how can you model the amount of JavaScript it produces? Well, you can say like, well, there is a content to the application, right? This is your application, how much you created. And this is multiplied by some marginal size of like, for every single extra feature I add here, how much extra code is produced on the other side. And of course, there is some cost to the framework itself. like so. And then this together produces your bundle size. And if you look at all the different frameworks out there, this is an example of like building kind of a pretend application of different sizes and then seeing what happens to the outputted bundle. You can see that different frameworks might have a slightly different slope, but they're all kind of in the same vicinity. And it kind of makes sense because most of the code just gets translated one for one. But what if we could have a flat line? Meaning that what if at the beginning of the application we wouldn't have any JavaScript, and only when the user starts interacting with the application we start downloading JavaScript? What if we could have this kind of what I call a resumable world? Before we jump into that, let's talk quickly about big O notation. In computer science, which you are all computer science, as you know, we have this idea of big O, meaning like, hey, if I double the amount of input, what happens to the amount of work do I have to do in order to process it? Is it linear? Is it n squared, which means if I double, I have to do 4 times as much work, like in the casing of like a bad sort? Or is it constant, like in the case of a hash map, right? No matter how big your hash map gets, accessing a particular item out of a hash map is a constant time. And so in this particular case, we would say it's O of 1. What I'm trying to say is, we have a situation where we're creating more and more JavaScript, and we are in the O of n world, where the more JavaScript we create, the more bundles we have to download in order to get the application going. And I don't see this trend stopping. Like it's not like we can go back 10 years and pretend like, oh, 10 years ago we weren't using this much JavaScript, but also the websites kind of sucked, and nobody wants to go back to that world. So if we do nothing, we're going to end up on this trajectory, keep going up and up as our websites become more and more powerful in terms of features that they deliver. What we need is a way of figuring out how do we break this? How do we go into the O of 1 world, where the initial amount of work that the browser has to do to get the website going is constant? So if you go back in past, you can kind of look at like, how do we get here? And the way we get here is we start in like the PHP Rails, basically server-side rendered world. And in the server-side rendered world, the sites were actually pretty performant because we were generating just HTML, and HTML is extremely fast at being parsed and displayed by the browser. So we had a very nice, snappy websites. The problem was they weren't very interactive. And so we had things like jQuery. The problem with jQuery was that oftentimes you had to write the same thing twice. You had to write it once in like PHP, this is what an address page looks like, and then you had to write it again in jQuery saying like, this is what the address page looks like after you have edited it. And as you can imagine, doing everything twice in 2 different languages, that's not a lot of fun. So over time, we basically favored systems that make DX better. And so we ended up in this world of component frameworks, right? Where everything is done in JavaScript, everything is component-based, and it's all about the DX. Everybody's chasing the best possible DX. But it comes at an expense, and the expense is hydration. The expense is that our applications start with a white page, then the JavaScript loads, and then you can be interactive. This white page is a problem, and so we say, we have a solution. We have server-side pre-rendering. And the server-side pre-rendering is kind of a lie a little bit, because what server-side rendering says is like, here's a page that looks like a page, but you can't really interact with it just yet. I have to really boot up the application and spend all this time doing work, then you can interact with it. And so my prediction is that in the future, we are really going to be focusing on performance. Like, yes, we want to keep our DX, but we also want to have a performant websites. And the problem is not that developers aren't trying hard enough. The problem is that the mental models, the way we approach the problem, and the way kind of tools we have need to change. And one of the ways I think this should happen is through frameworks we call Resumable. Now, it turns out Resumable is not a new idea. Google has been using a framework called Wiz for the past 8 years, and they have a Resumable framework that powers Google Search and powers Google Photos. And both of these applications, if you ever use them, are amazingly fast. As a matter of fact, I always find it interesting that if I want to spell check my word, the easiest thing to do is to just paste it into Google and see it over there. Like, it is that quick. And nothing you can do can make it so that the page is not ready for your interaction. The Google search really excels at the fact that as soon as you see something, you can interact with it. Now, it turns out there's eBay. eBay has Marco. Marco is another framework that is aiming for resumability. They're not out yet. It's not released. I mean, Marco is released, but the resumability part is not released. And of course, there's the framework that we work on, which is Quick, which has this resumability property. So what is this resumable versus replayable thing? So when I first saw virtual machines, I was really impressed. And the thing that really impressed me was that you could boot up, let's say I had a Windows machine. Inside of the Windows machine, I could boot up Linux. And then the Linux would go through its boot up process, which would take, back in the day, maybe like 2 minutes. And then after 2 minutes, the Linux would give me a login screen. I would log in. I would open up maybe a Word document, and I would go and type a letter. And at some point, I could save the whole VM into a file. And I could take that file and move it to a different physical machine. And when I opened that file in a different physical machine, it opened exactly where I left off. I wasn't going through a boot up process. I wasn't going through a login process. There was no reopening of the application. When the file representing the VM opened, it was exactly where I left it off. And that's resumable. Like, that's the idea of resumable. So what if we could have the same exact idea for our web applications? We run them on a server, which we already do because we server-side pre-render them. What if we could save everything in HTML and then move it over to the browser so that in the browser they can just resume where it left off? And when I mean resume, if you think about it, the application on a server is finished when it has nothing to do. So when it resumes on the client, there's actually nothing to do because the application is waiting for a user interaction. And it's only when the user interaction happens do we actually have to download some code and do some behavior. So if you look at it from what's happening is on a server, we execute our application logic. We then serialize the application into HTML, send it across to the browser. The browser has to download our application. Then it has to execute the whole application in order to figure out where the listeners are, where the component boundaries are, where the state of the application is, all of that stuff. That's what a framework does. Once it does that, it has to reconcile it against the DOM that's already in the browser, right? The reconciliation step, which basically usually involves re-registering all the listeners. And only then does your application become interactive. These blue boxes here on a mobile device and a 3G network can represent 30 or more seconds before the application becomes interactive. A resumable system is the same exact thing on a server. You still have to execute it, you still have to serialize it, except when you get to the client, all of the information that you need to continue is encapsulated inside of the HTML. And so the system is just ready to accept a user interaction without doing anything in between. Really, server-side rendering today is kind of like baking cake. Like, let me show you a page that looks like a cake. Oh, you want to eat it? Sorry, it's just a picture. I have to go and I have all the ingredients and I have to bake it for you, so give me some time, and when I bake it, then you can actually have it. And this particular analogy is actually kind of a problem, and it's the reason why our websites are kind of slow. I am running out of time, so I'm going to skip this. I just want to kind of talk about how we have kind of the existing set of frameworks that are replayable, and there is a new set of frameworks that people actually aren't very familiar about, Resumable, and I said, as I mentioned, Wiz has been around for a very, very long time, and Marco is something that's happening in the future. I don't know which framework will be popular in the future, but I think this idea of resumability and this idea of having a super fast startup is something that is here to stay. Now, there's another part to these kinds of frameworks, and that is that they are progressive. A traditional framework, before it can start up, has to be fully executed. So all of the JavaScript has to be executed right at the beginning. So right off the bat, all of the JavaScript is executed, downloaded, and then executed. Whereas in the Resumable framework, you start with very little JavaScript at the beginning, oftentimes as little as a kilobyte. And then only when you do an interaction does more and more code get downloaded. Now, before somebody says, well, what about waiting for a slow network? There's prefetching and other strategies to mitigate that. But the big difference here is we take the same amount of JavaScript, and instead of making our website dead and uninteractive until all the JavaScript downloads and executes, we flip it around. We said the website is interactive, and as you interact, more and more JavaScript can be downloaded. Now, the thing to notice is that the amount of JavaScript will actually never equal the amount of full JavaScript, because there's a huge amount of code in your application that executes exactly once on application startup. And because that code executed at a server and then we resume the application on the client, that code actually never comes to the client to begin with. All right, as I mentioned, all frameworks are not new. The thing to kind of note here is that all frameworks really claim that they're fast. And so there is runtime performance, which you see graphs like this. These kinds of graphs really focus on the performance of already running application. But the thing that I really would like to talk about is, what about the startup performance? And if you look at the startup performance of different frameworks, this is a to-do application that was built using mitosis. Mitosis is a technology which allows you to build an application once and then generate it for all the different frameworks out there. You can see that what's really correlated is the amount of JavaScript that's required, which is the green bar, in these frameworks. So frameworks that have a really slow startup times also download a huge amount of JavaScript. So blue and the green line are correlated, right? You have a lot of JavaScript, of course you're slow to start up. You have very little JavaScript, well, of course you're fast to start up, right? So what we're going after is minimize the amount of JavaScript. I am out of time. I had a few more slides, but I'm out of time, so I'm going to stop here. I will be hanging out in the background somewhere over here, so you're welcome to come and chat with me, and I'm happy to answer any questions you might have.